Alrighty, so this video we're going to be talking about two variable relationships, also known as inverse and direct proportions. Okay, so we're looking at how can two things be related when they are proportionate, or how do we describe the relationship that they may have? Okay, so a few reminders for you. The first is that functions are a relationship where each input has exactly one output. Meaning that if we have something that goes into the function, an x value, we're going to get exactly one y value from it. The next reminder I have for you is exactly related to that the inputs in math are the x values. They are our controlled or our chosen variables, also sometimes known as our independent variables. Okay, these are the ones we are choosing and we are determining what happens. Okay, and lastly then, if we have independent variables, we also have dependent variables. Those are our outputs or our y values. They tell us what happens when we have an x value and we do some change to it and something happens. So it's that something that happens. Okay. So the first type of relationship we're going to talk about is our direct proportionality. Directly proportionate things. Directly proportionates are a function with a constant rate of change between the x and the y value. Okay, the x and the y are going to increase at the same, or the y is going to change at the same amount, a constant rate as the y, or as the x value increases. Okay. Direct means that whatever happens to one variable has the same impact on the other, meaning that when I change my x value, it is going to have the same impact on the y value regardless of what my x value is. So whether x is 5 or x is 35, okay, we're going to see the same impact happen. We see directly what happens. Proportional is our word that refers to things being related. So that just means that these two things are related and they're going to change in some way that we can represent mathematically. Okay. We write about direct proportions using this symbol here. It looks like half of an infinity sign or a sideways 8 that got its tail cut off, okay, or like a little fish. And that sign just means proportional, okay? All directly proportional relationships are represented with y proportional to m times x. And really what we typically use is k. So I'm even going to change that right now. And this is a multiplication happening. So I'll even put in y is proportional to k times x. All right? We're going to, all right. So that is our setup that we always have. Y is proportional to x by some constant value for k. And the k represents the constant. So that is by what we are changing, okay? The last piece that's really critical to be a dependent, or a direct proportion is that we have to cut through 0, 0. A relationship is not directly proportional if it does not go through 0, 0. Okay, so that's a really important point. So I'm going to draw a little example for you. Alrighty, so I'm going to show an example here. My example is going to say y is proportional to x by a constant of 2, saying that x is going to be impacted by multiplying by 2. So remember, this is our independent variable. Y is our dependent variable. And 2 is our constant, or that thing we're multiplying by, okay? So I'm always going to go through 0, 0. And what this says is that when my x value, for every x value I put in, I'm going to multiply by my constant. I'm going to make me a little table to help me remember or keep track. So when I put in 0, let's look. Y is equal to 2 times 0. Y is equal to 0. Because 2 times 0 is 0. Okay, so I got 0, 0. That's good. That's a good first sign. Let's plug in 1 for x, so y is equal to 2 times 1. When I do 2 times 1, I get 2. So I can plot that point 1, comma 2. Next, I'm going to do 2. Y is equal to 2 times 2. 2 times 2 equals 4. Okay, so 2 comma 4 is the next point. And I can get kind of wild and crazy here. If I put 5, we'll skip over a little bit. Well, let's plug that in. Y is equal to 2 times 5. It's equal to 10. You'll notice that whatever is in my x value, we doubled to get to our y value, which is what times 2 really is. So I'll put a point there at 5 comma 10. And you will notice, if I'm good enough at drawing this, and we'll see if I got it in me today. Oops, I'm getting a little off kilter there. But if I was really rocking it with my drawing, you would see that I was going through the points 4 comma 8 and 3 comma 6, which makes sense because each of those, the x times 2, gets me my y. So this is an example of a direct proportion because I'm going through 0, 0, and I have my x value being multiplied by my constant to get me my y value, and that works for every point on that line. Okay? Some examples of where we see direct proportionality. So these are things where when one thing is increasing, it always increases by the same amount. An example would be the miles driven and time passed when going the same speed. So if you're like on the highway and you're going 65 miles an hour for an hour and a half, right? However long it takes, I'll show you an example. So if this is my minutes and this is my distance, as the time increases, how far away from home you are is gonna increase at the same amount. It's not like between minutes 5 and minutes 10, that's gonna be some kind of different change between, if this is 5, this is 10, and this is 15. This gap here is gonna be the same as this gap here, so you know that they're going the same amount, okay? Another example would be, this is a really common one, the money earned and hours worked. Okay, the more hours you work, the more money you earn. Okay, if you're earning a steady pay, no overtime or double bonus or anything like that, the more hours you work, the more money you make. Okay, and lastly would be, another example is how much of an ingredient is needed for given batches. There we go. So these are some examples of direct proportional relationships. Now we're going to do an example using direct proportions to solve, okay? So my example here is on the back of the worksheet that goes with this. So if you're following along on the worksheet, that would be where you would find this. All right, so this example is on the back of the worksheet, okay? If you are following along on the worksheet, let's get rid of this little piece here. Boop, 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 okay. So it says for each hour that Jackie works, she earns $15. How much can she earn if she works 6 hours, okay? So first, what I wanna do is I wanna identify my pieces. 15, it looks like, from my equation, is how many hours worked, okay? Money made. Let's do some cleaning up. 15 is how much money is made per hour, okay? Well, if that's per hour, what is the thing I can control? Can I control the total, or can I control how many hours I work. Well, I can control how many hours I work. So we are going to say X, or our independent variable, is the hours worked, which tells us that my output, or my Y value, that is going to be the money earned, or my dependent variable, because how much you make depends on how many hours you worked. So we're going to plug in our key pieces here given our information. Well, we don't know what the total is, but we know that Y is proportional to X by a constant of 15. Okay? And we are solving, so we're going to switch from the proportional sign to an equal sign when X equals 6. Okay, well, when X equals 6. So I'm taking 15 times 6. 15 times 6 is 90. Okay, so we know that Y equals 90. So then I can write $90 earned. That is my answer. Okay, so I used a proportion, or a relationship between numbers, to solve for an unknown value. You'll notice that I use my proportional sign when I'm making a statement about the relationship, and then I switch to an equal sign when I start solving. Make sure that you use units to describe what your answer is.